My dear students, already I have discussed about the stopping potential and the retarding potential, how it is related, all these things. In previous video clip, it is very important point you have to take that. That point is said to be stopping potential depends on frequency. Stopping potential depends. For with the help of this graph, the resulting graph you have to draw. Effect of frequency of incident radiation on stopping potential. How it affects stopping potential. The frequency's effect on the stopping potential. It means stopping potential, how it is related to the frequency directly. Now, at that time, you draw the graph frequency along x-axis, stopping potential along y-axis. Stopping potential is measured in what? Okay, now see here. Now frequency is go on increases, stopping potential is also increases. Stopping potential is also increases. At one particular frequency, stopping potential becomes zero. Stopping potential becomes zero. That frequency is called threshold frequency. This is for one particular metal. Another metal means this is a photosensitive metal, this is material. For another metal change ಮಾಡ್ತಾನೆ ಇದೇ experiment ಒಳಗೆ ಈ metal change ಮಾಡ್ತಾನೆ. For another metal, you got another threshold frequency. Threshold frequency depends on what you say, nature of the substance. Now one more important point, stopping potential. Stopping potential in volt is equal to kinetic energy of photoelectrons. Kinetic energy of photoelectrons in electron volt. Stopping potential volt ನೊಳಗೆ ಎಷ್ಟಿರುತ್ತೋ kinetic energy of the photoelectrons electron volt ನಲ್ಲೂ ಅಷ್ಟೇ ಇರುತ್ತೆ. ಹಾಗಾಗಿ ಫ್ರೀಕ್ವೆನ್ಸಿ ನಾವು ಏನಂತ ಥ್ರೆಶೋಲ್ಡ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಅಂತ. ಇವಾಗ ಇಲ್ಲಿ ನಾನು ಹೇಳ್ತೇನೆ ಏನು ಇಲ್ಲಿ ತೋಳ್ತಾನೆ. ದಿಸ್ ಈಸ್ ಟು ಟೇಕ್ ದ kinetic energy of the photoelectrons. Kinetic energy ತೋಳ್ತಾನೆ. This is said to be frequency here. Again you got the graph like this. This is for metal A, this is for metal A, this is for metal B. Very metal, metal. You got this is the threshold frequency. Threshold frequency. Now this graph in this region greater than the threshold frequency. Incident frequency of light is greater than the threshold frequency. You got this one like this. Now this is the threshold frequency. The threshold frequency ಕಿಂತ ಕಡಿಮೆ ಇದ್ರೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಮಿಟ್ ಆಗಲ್ಲ, ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಇರಲ್ಲ. ನಾ ಹೇಳ್ತೀನಿ ಇವಾಗ ಇಲ್ಲೇ once the radiation is incident on this one, nu greater than nu naught, the incident frequency of light greater than the threshold frequency, at that time the electrons are emitted and they move towards the anode or said to be collector. At that time they have the kinetic energy. They have the kinetic energy. Now this kinetic energy, you draw the graph along y-axis, frequency of incident light along x-axis. Now where is the frequency? Rather than this one, go on increase this one. At that time you got the kinetic energy. Once the frequency is gone decreases, at one particular frequency there is no emission of photoelectrons. That frequency is called threshold frequency. It means there is a minimum frequency of the incident light on a photosensitive material. Below that frequency, there is no emission of photoelectrons. This is called threshold frequency. This threshold frequency, it is represented by what you say, mu naught. Mu naught is said to be threshold frequency. If incident light frequency is greater than the threshold frequency, there is no problem. Photoelectrons are emitted, they are moved towards the collector. If it is equal to threshold frequency, the photoelectrons are just emit but not moves. Less than the threshold frequency, there is no emission of photoelectrons. That is said to be threshold frequency. That minimum energy required to emit the electron, to liberate the electron for photosensitive material, that is called work function. ಅದಕ್ಕೆ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ, ವರ್ಕ್ ಫಂಕ್ಷನ್ ಅಂತೀವಿ. ಆ ಫ್ರೀಕ್ವೆನ್ಸಿಗೆ ನಾವೇನಂತೀವಿ, ಥ್ರೆಶೋಲ್ಡ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಅಂತೀವಿ. ಅವಾಗ ವೇವ್ ಲೆಂತ್ ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್, ಥ್ರೆಶೋಲ್ಡ್ ವೇವ್ ಲೆಂತ್. Once again I repeat. Now see here, a very important point. There is a minimum frequency of incident light. Below that frequency, there is no emission of photoelectrons. This is called threshold frequency. ಅದನ್ನೇ ವೇವ್ಲೆಂತ್ ಹೇಳ್ಬೇಕಾದ್ರೆ ಮಿನಿಮಮ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಅನ್ನಬಾರ್ದು, ಮ್ಯಾಕ್ಸಿಮಮ್ ವೇವ್ಲೆಂತ್ ಅಂತ ಹೇಳಬೇಕು. There is a maximum wavelength of the incident light. Above that wavelength of light, there is no emission of photoelectrons. This is called threshold wavelength. This is a threshold wavelength, the threshold frequency. Okay. Now, kinetic energy of the photoelectrons is directly proportional to frequency of the incident light. Incident light. And one more experimental result, fourth one. The photoelectric current, or number of photoelectrons emitted per second, is directly proportional to intensity of the incident light. This is the fourth result. And one more very important point result is the photoelectric effect is instantaneous process. Instantaneous process, it means it happens when the light is incident and photoelectrons are emitted. It happens in the within the 10 to the power of minus 8 seconds. It is very, very, very less time. In the fraction of second, the photoelectrons are emitted. Therefore, this is said to be instantaneous process. This is said to be instantaneous process. Now, very, very important experimental result. Once again I repeat. One is, now see here, the photoelectric effect is instantaneous process. What is the meaning of this one? What is the meaning of this one? If the light is incident on the photosensitive material, within fraction of second the photoelectrons are emitted here. Second result, there is a minimum frequency of incident light. Below that frequency, there is no emission of photoelectrons. And next result, the maximum wavelength of the incident light. Above that wavelength of light, there is no emission of photoelectrons. And fourth point, the kinetic energy of the photoelectrons. The kinetic energy of the photoelectrons is directly proportional to the frequency of the incident light. In other words, the stopping potential is directly proportional to the frequency of the incident light from this above graph. And lastly, the photoelectric current is directly proportional to intensity of the incident light. That light frequency should be greater than the threshold frequency. These are the very, very important 5 experimental results of the photoelectric effect. This is about what you say, the photoelectric effect. ನೀವಿಲ್ಲಿ ಎಲ್ಲಿ ನೋಡಿದರೂ what type of mechanism takes place when the light is incident on that photosensitive material, that point is cannot explain by this experiment. ಈ experiment ನೋಡಿ ಎಲ್ಲಿನೂ ಆ ಪಾಯಿಂಟ್ ಬರೋದಿಲ್ಲ. ಈ ಪಾಯಿಂಟ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ ವ್ಯಕ್ತಿ ಯಾರು? The name of the scientist is Einstein. Therefore, that equation is called Einstein photoelectric equation. It is one of the famous equation, very, very important equation. Einstein photoelectric equation, photoelectric effect equation. ಅಂದ್ರೆ ಐನ್ಸ್ಟೈನ್ ಏನ್ ಮಾಡ್ದ, ಕ್ಲಿಯರ್ ಏನ್ ಮಾಡ್ದ ಅಂದ್ರೆ ಆ ಪಾಯಿಂಟ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತಾನೆ. ಯಾರು? ಐನ್ಸ್ಟೈನ್. ಇಲ್ಲಿ ಎಕ್ಸ್ಪೆರಿಮೆಂಟಲ್ ರಿಸಲ್ಟ್ ಒಳಗ ಆ ಪಾಯಿಂಟ್ ಎಲ್ಲಿ ಬರೋದಿಲ್ಲ. ಸಪೋಸ್ ಈ ಫೋಟಾನ್ ಇನ್ಸಿಡೆಂಟ್ ಆಯ್ತು, ಇನ್ಸಿಡೆಂಟ್ ಆದ್ಮೇಲೆ ಮಟೀರಿಯಲ್ ಒಳಗೆ ಏನಾಯ್ತು, ಇದನ್ನ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ ವ್ಯಕ್ತಿ ಯಾರು ಅಂದ್ರೆ ಐನ್ಸ್ಟೈನ್. ಐನ್ಸ್ಟೈನ್ ಮತ್ತೆ ಏನ್ ಮಾಡ್ತಾನಲ್ಲೇ ಇದ್ರ ಬಗ್ಗೆ ಹೇಳ್ತಾನೆ. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು.